Okay, in this section, chapter 2, we are going to learn describing, exploring and comparing data. We'll go one by one. Just an overview. So after we collect data, we are going to see how we can organize. If it's a big data set or the small data set, we'll see how can be effective way you can organize that particular data. So we collect data because we wish to explore what important information on the data set you can learn about. The way in which we analyze the data set will depend on whether we have a sample data or a complete population of data. So either way, we had to study about that. Explained to you in the previous section, there are two different types of statistics. One of them is descriptive, other one is inferential. The descriptive means you have to summarize, describe the important characters of the data set. That's the part you are going to learn under chapter 2. So, before you go and analyze the data, you have to know the important information of the characters of the data. The first thing we call the center. The center means the average or the middle of the data, a representative or average value that indicates where the middle of the data set is located. Such the same way you have learned before, mean, median, mode. Those are the three things represent the middle of the data. When it comes to the question, we'll learn how to calculate those values. Variation. The variation means a measure of the amount that data values vary. For example, if you find out the mean, so you have to think about the rest of the data, how far from the mean. Sometimes that is higher than the mean, sometimes lower than the mean. No matter what, you have to know the data variation. That's another thing you have to know about the data. Distribution. The nature of the shape of the spread of the data over the range of values, such as we are going to learn later on the normal distribution, uniform distribution, skewed to the right or the left. Any kind of difference in the distribution you are going to learn under data set. Outliers. You heard about this before. What does outliers mean? If you have range of data, one or two or more few data away from the most of the data we call outliers. For example, your range of data in between 30 and 55. If you see one of the data is 95, that is away from the most of the data. So we call that 95 is outlier. The same way, the data range is 25 to 50. If you see one of the data is 1 or 2, that is away from this data on the other side, still we call that is an outliers. Time. Of course, time is the most important part when it comes to data. So over the time, you have to study what happened to the data. The key concept. When working with a large data set, it is often helpful to organize and summarize data by constructing a table that is called the frequency distribution. So simply, if you have 100 or 200 data, it's hard to organize on the table. So instead of that, after you learn frequency distribution, we can put them into smaller rows. That means you can put them into class intervals, some range of data within the class. So that's the way you can reduce the big data set into small data set. We'll see how to create the frequency distribution in the later slides. Because computer software and calculators can generate frequency distributions, the details of constructing them are not as important as what they tell us about the data set. Of course, in your lab, you will learn how to organize or set up the distribution or the frequency distribution table using software. But when it comes to your exam, you have to know how you can create this table manually. So better you have to learn at this point. Frequency distribution. That's the first distribution you are going to learn under statistics. shows how data set is partitioned among all of several categories or the classes, right? For example, if you have a range of data, you had to organize how you can split this into equal class interval. That's the thing you are going to learn under frequency distribution. So by listing all of the categories along with the numbers of data values in each of the categories. Here are the examples. Here are two different types of frequency table you can see. The first one is the single data, right? This is the example you have learned in your school life. If you have a score, so if you are using the tally mark, then we can find out the frequency. Go and count these tally marks. For example, 4 means you can write it down 4. If it is 9, 9, and so on. But here the most important part, how to create this particular type of frequency distribution. That is called group data. The group data means if you have a big range of numbers, for example 40, 50, 100, we can reduce this into class limits. You can create in between 0 to 10 or 1 to 10 one of the classes, or 11 to 20 is another class, and so on. That's the way we can create the lower class limits, not lower class, reduced class limits. You see in the next slide. This is another examples of group data. Example number 1. If you have a data set, here we have only 10, right? That's a small data set. If you use the numbers or the frequency table, there's no difference. But I'm going to show you using the simple example how to create the frequency table. Before you start your frequency table, you have to know the range of this data. How to calculate the range? What's the maximum value minus minimum value will give you the range. After you figure out the range, then you have to find out how many equal classes you can create using these numbers, or what are the number of classes you can create using these numbers. So if you want to find out number of classes, you have to divide them into equal class width. So I'll show you in the next slide how to create the equal class width. So first choose equal intervals. For example, our range from the previous example, you can see the maximum number is 40. So that's the highest value. The minimum number is 5. What's the range for those two numbers? 40 minus 5 is 35. So you had to have the range value of 35. You had to think about how to create this as an equal number of class width. So in this example, I'm going to choose 10 as my class width. If 10 is my class width, then you have to think about how many classes you can create. That's an easy way, or we have a formula to find out number of classes. The formula for that, number of classes equal range divided by class width. Or if you want to find out the class width, you can find out range divided by number of classes. Either way, you can find out class width or number of classes using this formula. In this example, the range value 40 minus 5 equal 35 divided by, if I want to choose my class width as 10, so 35 divided by 10 equal 3.5. So always you had to round up that number, not round down, you had to round up. 3.5 moved to 4. Even though if you get 3 or 3.1, always you had to move 1 up. So in this case, I got 3.5, I move up to 4. That's the meaning. I'm going to create 4 classes with each class 10. The class width is 10. So you can see here 1, 2, 3, 4. 4 classes, each class width is 10. How to calculate the class width? For example, 1 to 10. You can manually count 1 up to 10, or how to find out 10 minus 1 equal 9. Always you had to add 1 to get the class interval. So 10 minus 1, 9, 9 plus 1, 10. That's the class width for this one. The same way here, class width 10, class with 10, class with 10. We are fine. Next, you go and find out within the range of 1 to 10 how many values located. So manually you can say within 1 to 10, in the previous one, how many values located. Here you can see 1, 2. Only 2 values are in between 1 and 10. So the frequency for that, 2. The same way you can find out how many values in between 11 and 20, that is 4. Same way 21 to 30 is 1, 31 to 40 is 3. That's the way you can create your frequency table. You can create this as a horizontal way or the vertical way. Next example, that is your turn. You try yourself and see how can you create the frequency table for that. After you try, so check with my answer. Right. So we have done with a small data set. If you want to work with a big data set, something like this, so you have to know, if you know how to create the frequency table, when it comes to the very big one or the big one or the small one, we had to use a small approach. So here's an example. The first thing you had to find out what's the maximum value and the minimum value. There are 2 data sets I'm going to use for females. The maximum is 124, the minimum is 60. So when you go and subtract, you will end up with the range value 124 minus 60 equals 64. So think about 2 ways. You can think about number of classes or the class width. I want to keep my class width as 10. If you know that, that is your option. You can select your class width as 5, 10 or and so on. Most of the time I prefer 10 because you can observe the pattern if you choose the 10 value. So in this question also I am going to choose my class width as 10. The range 64 divided by 10 equal 6.4. When you round up, go to 7. So now I know all the information. Class width 10, number of classes 7. So using that concept, I'm going to create my frequency table. One more thing you have to know that how to select the lower bound value. So here 60 is our lowest value. So it's already the perfect value. You can choose 60 as your lowest one, first value. If it is 61 or 62, of course all the time you can use that value. Always you have to go further down to get the good numbers. Then only you can observe the pattern. So here I'm going to choose 60 as my first value. So my first class going from 60 to 69. Then go and figure out how many values are in between 60 to 69. I found out there are 12 of them in between 60 to 69. So using that, I have created my frequency table like this one. Right? The same way, if there's a different data set, you can create that. Right. So next, lower class and upper class. So I'll show you the rest of the part is another lesson.